The power of one. Hello. Welcome back to Math Time with Professor Prime, and I am your host as always, Professor Prime. And today we're going to be talking about the power of one. So why did I do that? Well, when I conceived of this video, I wanted to name it The Power of One. And when I did that, I doomed it to sound like an 80s power metal ballad. And so I felt like that opening was appropriate to it. And so let's get into the video though. So we're going to be talking about the power of one. And to start, one is oftentimes considered the loneliest number, and I'm out to disprove that. Okay. I need to cool down and then we can just zoom into the video. So you know what? We're good. Allegedly. Let's go. Take it away. Me. Thank you, me. So let's get into it, shall we? I feel like one gets overshadowed by a lot of other numbers and concepts in math. And I think that's unfortunate because everything kind of starts there, right? Like first I have nothing, then I have one. And then if we're looking at counting numbers, aka natural numbers, aka whole numbers, what happens after that? We get 2. And what is 2? It's 1 plus 1. And then we get 3. What is 3? It's 2 plus 1 or 1 plus 1 plus 1, right? And the thing is, we can keep on playing that game, going further and further and further. If we have something like 2 million, then we have 2 million ones all added up together. In other words, a whole lot of ones. And so I bring this up though because it's more convenient to use the words that we have for those numbers in order to describe what's going on rather than saying like, hey, we added up one this many times. Because like even if I look at 3, right, it's 1 plus 1 plus 1. That's another way to talk about it. That starts to become long. If I got to 4, it's like 1 plus 1 plus 1 plus 1. I get to 5, it's 1 plus 1 plus 1 plus 1 plus 1. Hopefully that worked out how I meant for it. But the idea is like there's 5 ones added up together. So my whole point though is like we started at 1. And then when you look at the numbers in between, when you talk about like fractions and decimals, for instance, they are part of something, right? They're part of 1. They're part of a whole. They're part of this number or that number, right? That's the kind of idea that I want to get across. And then when you talk about percents, same deal, right? It's just another way to talk about being part of a whole. And then when you think about what percent actually is, it translates to per 100. So if I have something like that, then that's what I'm getting across, per 100. So if I have something like 42%, then yes, I could say that it's 0.42. But in fraction form, it's 42 per 100 or 42 out of 100. And so all those are the same thing. 42% equals 0.42, which equals 42 out of 100, which could be simplified, of course. But I bring that up because when we talk about like 100%, what are we getting at? It's just a quantity, like the other things. It's 100 out of 100, aka 1 out of 1, or simply 1. And so yeah, when you're talking about percentage, you're talking about something as part of a whole. Same with fractions, same with decimals. So I think there's something to be said about that. And then when you get into the uses, it shows up all in math. Like one of the cool properties about 1 is if you multiply anything by 1, it's going to be itself. If you have something divided by itself, it's going to be 1. Both of those are useful when you're adjusting fractions, for instance. If you had two fractions that had like uncommon denominators, there's a better way to say that. But my whole thing is like if they didn't have like denominators, you could adjust, and 1 gets helpful with that. So I won't go into it fully here because I do feel like visual aids will like help with that. But you know, that's a whole nother video for another time. But like, let's say if I wanted to say something like 1 out of 2 or 1/2, and I wanted to talk about the same sort of whole is like 1/4, then in order to adjust that, I want the denominator to be 2. And so what do? I can't just multiply by 2 in the bottom because that just means I'm like taking um, something that isn't true and changing the quantity that I'm talking about. But if I do 1/2 times 2 over 2, then we're cooking with oil, right? Because then I get 2 out of 4, which is the same quantity as 1/2, but then I could talk about that in terms um, of the other number that I'm adding. So like if I was saying that I'm adding 1/2 plus 1/4, if I make that adjustment that I just talked about, then I have 2 out of 4 plus 1 out of 4, which equals 3 out of 4, which we'd expect, right? Like a half and a quarter gives us 3/4. But yeah, I didn't want to go too far into it because I didn't have anything up on the screen. But I bring it up though because it's useful for that. It's useful for making conversions, like regarding measurements, because we like to think about like those properties that we mentioned with one as being just useful for explicitly numbers, but it works with units as well. Because let's just say something simple like time. Simple like time. I don't know. That wasn't the best thing to say. Time isn't simple, but I want to talk about that for an example though. So we know that 60 seconds is 1 minute. Um, and so the idea is like they represent the same quantity. So if I had like 60 seconds over 1 minute, that's the same thing as just saying one without units. And that's also the same thing as saying 1 minute over 60 seconds equals one, again, without units. So that is a bit useful though for when we're converting because if we had to convert, we can multiply by that sort of quotient and then we're getting somewhere. But again, more on that in another video because I didn't want to go too far into it. But my whole thing is like it could be used in all those things, and we don't have anything else if we don't have one. If we didn't start there, so I think that's pretty cool. Yeah, so I hope this was helpful in some way. And again, I could get carried away and talk about some other things, but I feel like I should flesh some of this out in another video. So that being said, one is powerful, and I feel like that works in math, but also for the individual. We have more power than we think. Just saying. Something to consider. So that being said, Professor Prime out.